saw you.
Okay.
It's a transferable.
Yeah. Transferable.
Bro, you learn English.
Tomorrow's Thursday.
Yeah. I was just Friday.
Oh.
Alright.
Okay, girl.
Absolutely great program.
Alright. Thank you. Alright. Thank you. And then Esther, I have those. Okay. So our test will be tomorrow. You guys will get a review tonight as homework, which is kind of like sample test questions. I don't do it like, so those of you guys who've had me before, with these more upper level classes, I'm trying to do less of the review where I go through every type of problem and kind of like talk you through it. It's more that you guys should be figuring it out a little bit on your own and deciding if you guys understand or if you need help. So you guys will have time to work on the review together and use that time so that you guys can get yourself prepared. So for the test though, you can use a calculator. You should use a calculator. You need to bring one. I do have some on my desk, but understand that the ones on my desk, only as many as I have. You cannot share one. Yeah.
I have sheet paper.
Yeah. Yeah, I forgot you can. I was so excited. Yeah. Too busy for me, college girl. All right. So you cannot share a calculator. So Owen and I couldn't share the same calculator and pass it back and forth throughout the test. If you understand how the calculator works, I would be able to look at like all the things he did. So that would not work. I mean, if I would share with any of you, but copy off the teacher. All right, and you can make a cheat sheet. Now, I do that partly because I think that's always what Mr. Hatfield always did with pre-calc and trig, and I'm okay with that. Just know that, like, I don't make a small cheat, like a whole page of notes. So you can just use like a regular sheet of paper. You want to put your name on it. You want to probably put the title on it because I'll hang on to those until the end of the semester. And then when you guys go to make your note card for your exam, you have a bunch of cheat sheets that can kind of help you build that. Does that make sense? And then if you need to retake or something, you can use that cheat sheet again. So I hang on to them along with the tests. So you can make a cheat sheet. So our sections that we covered were just these 4 sections. In section 1.1 is where we talked about just regular right triangle trigonometry. So that was SOHCAHTOA. So right triangles. So I kind of just go through this to make sure you have all your different note sheets to kind of double check before you go into the test. I'm not going to spend a lot of time talking about this. In section 2 is where we got into our laws, so law of sines and cosines. Now I'm going to beg you to make sure you put your law of sines and cosines on your or on your cheat sheet correctly. Going into a test, just kind of assuming I don't need them. You just get nervous and you change your 2 to a 4 or something goofy, or like just something strange that you didn't mean to do. You get nervous on a test. For whatever reason, the cosines and area formula, I always get those 2 mixed up, and I always want to put cosine in my area formula. So just things like that, put those on your cheat sheet. That way you don't have any issues with that. So. Now, so law of sines and cosine, you should be able to solve a whole triangle, find all the different parts, be comfortable with that in whatever calculator you're using. The next chapter we got into area and perimeter. So area of a triangle and perimeter. Now I put a lot more on the review with area, and I'm not going to have a ton on the test with area, but on the review I put a bunch because I put a few questions where you maybe have to use some of these, like this trig to figure out the area. So I try to kind of combine some of these sections together. So the review probably has more area problems than the actual test will have. and that's of triangles. And then section 1.4 is when we did our application problems. So that was yesterday with our poker game, being able to set up a problem and solve it using our trig. So now I would highly suggest, some of you guys are definitely not show your work type people, but understand that the more work you guys can show on the test, the better off I can help you to give you guys partial credit. I mean, if you don't show any work and you have 100% correct, we probably don't have an issue. But if you don't show your work and you make a small mistake, it looks just like a big mistake to me. Because I'm not going to spend time trying to figure out what you did and try to kind of like go into your brain there with that. So show me what you're putting into your calculator, even if you just set up the equation or whatever, show me probably more than you want to. And especially with the application problems, draw a picture. Like show me what you're seeing, because let's say a lot of you guys, your picture, like when you came up for help yesterday, I'd say, what does your picture look like? And a lot of you just had your angle in the wrong spot, and I could easily tell what you meant to do, and that helps me to be able to help you or give you partial credit. So that's my begging to you to do show your work. So we're going to go through just a few application problems. I thought they'd be good to go through. Again, these are ones that were yesterday's problems that either you didn't get to, you struggled with, or maybe you did fine on them, but I figured we could talk about them. So these are all ones you might have seen yesterday, or maybe you didn't. So I wanted to definitely talk about these. And then I thought they were good because they reviewed all the different topics. They review SOHCAHTOA, they review area, and they review law of sines and cosines. So it says Kevin surveyed the triangular piece of land he purchased. So let's say he purchased a piece of land that was a triangle shape. He wrote down these measurements, and we want to figure out his square footage of his land. Why he wouldn't figure out and measure that side, I don't know, but apparently Kevin wasn't thinking, or he knew he could do trig. So we want to figure out the area. However, our area formula, the way it is right now, we do not have enough information. Because that area formula, the A and B we're talking about, are the sides that are around that angle. Again, I always want to put, that should be a capital C, I always want to make that cosine, so if I ever write it that way, please stop me and tell me not to. I always want to put, I don't know if it's ABC or something, that I want to make that cosine. So that means if this is the angle we know, we have to find this side over here. So like if I call this like little a, I have to find that. All right, so thoughts on how to find little a? You probably have to do law of sines, but it probably is going to take 2 steps, I think, right? Because we don't know the other angle. So I'm going to call, like just to label this, I'm going to call this big A. I'm going to call that big C, sorry. So I have to figure out little a, but I have to do a little bit of work. I can't do Pythagorean theorem. Law of cosines isn't going to work because I don't know the angle and side across from each other there. So I'm going to do sine of 55 goes with 498. And then I'm going to have to do B and figure out so this is definitely a little bit trickier one because I'm going to have to do a couple of steps to get there. And again, you definitely want a calculator because if you're able to do those without one, maybe you're cheating or so cross multiply here. And then I'm gonna do the inverse sine to find out b of that whole thing, which ends up being like 0.8685.
So you're taking that left part of the equal sign?
Like, yeah, this over here, the inverse sine of that whole thing.
Okay, I got that answer, but I just like divided 188 by 432.5.
Yeah, you were just doing it in 2 steps. Yeah, that's fine. That'll work. Yeah. No, that's. I think I have bruises continually around, like my thighs around that height because I walk into things all the time as well. Angle B ends up being like 60.3. Is that what you guys got?
Yeah.
So 60.3. Now again, I'm not done yet. I still have to find little a. Oh, unless we
Can't you just use the big A as the angle of the area?
Yeah, but oh yeah, we could do that. We could change that up. That'd be probably better. Yeah. So we'll try. So I'll do what we just said here. So we found big B. I think I was so focused that we knew that angle before. Now I can find big A. So 180 minus 60.3 minus 55, and I get 64.7.
How come that 64.7 is so smaller?
Because my drawing's not good. Because Kevin didn't do a good job of drawing his land. Okay. So yeah, don't let my drawings throw you off. And just like if you guys were drawing this, I hope you wouldn't feel like your drawing doesn't have to be perfect. It's just we're labeling everything. Don't let that freak you out. So yeah, what I would do instead now, thanks for pointing that out, is instead of going and finding little a, we don't really have to because we have now these 2 sides around that angle. So I would use now, I kind of change my formula up a little bit. I do 1/2, and I'm going to basically use these 3 here. It should give us the same area. Now, if you're like totally nervous that that's not going to work, go ahead and find little a and go ahead and do that, but it should be very close in an answer. It just would probably be a little bit off because of rounding. And this is going to be our area. And it's like 118,000 square feet. And remember, it's land, so it's not. Try to be good about units, especially degrees. So degrees for sure, put degrees on it. If it's square feet, square miles, what are we talking about here? That's a big difference if we're talking about square feet or square miles in terms of land. Either you own like a whole town or a whole state here or something, so yeah. All right, questions there at all? So I thought that was a good one because it talks about area, but it also did law of sine. So I thought those 2 together were good to review. So probably not something this complicated for a test, but the 2 parts separated are doable, finding area and finding law of sines. All right, if you guys want to flip it over, this was number 6 on our poker game yesterday, and this was one if I handed you the card, I'm like, oh, this is a rough one unless you just grabbed it and I didn't get a chance to tell you that. So this was definitely a tough problem. I had a few people solve it, so those guys who did a good job, but it definitely was one that I knew would be tough going into it, so I put a star on it. So it says Matt measures the angle of elevation of the peak of a mountain as 35 degrees. So first of all, it probably totally bothers you, but when we're talking about the peak of a mountain, I'm not going to draw my mountain this way because I'm just going to get confused. So I'm not going to draw like an actual mountain. I'm going to say the peak is up here, and that's going to be the height of that mountain. So Matt is looking over here, and he tells us he's looking up at it at a 35-degree angle. So that's Matt. Clearly. All right, and then Sue, who is 1,200 feet closer on a straight level path, which happens all the time in the mountains, she's 1,200 feet closer to the mountain. So we're moving Sue in here, closer, 1,200 feet. So we're gonna put Sue here. And this is gonna be 1,200 feet between them. And she's looking up at the mountain at an angle of elevation of 42 degrees. We want to know how high the mountain is. So this is kind of a two-part problem. This is definitely a tougher question. So if this bothered you or you had a hard time with it, it's totally understandable. Kind of our chess match here, how we're moving from step to step, like what's our plan? I'm going to figure out what this distance is here. I'm going to figure that out because I want to look at this as a right triangle. We're assuming height is measured straight up and down, so that's why it's the right angle. It's not because the mountain is set at a right angle with the ground, like this isn't just like a straight wall mountain, but the elevation is that way. So we're kind of looking at two separate triangles. So if it's helpful to kind of draw them separately. So I'm going to look at just this part right now of that triangle. So you can kind of tell when I try to take out just like the left side here. Okay? So this is a 35-degree angle. This is 1,200. I want to figure out this y. Do I know anything else?
I know what the other angle is in the
Yeah. Yeah, these form a straight line here.
It's 130 degrees.
138.
Yeah.
Okay. Then I know the top angle, right?
7 degrees.
7. So very small angle there. But now I have enough information to do law of sines. So I can do law of sines. I kind of wanted to do a law of sine or law of cosines practice, but that's okay. You'll get plenty of it on your review. So, a question?
Where do you get the sine from?
Because the angles add up to 180 degrees in a triangle, right?
Yeah.
Is that okay? No, it's okay. We did that. We did it kind of fast, and yeah, no, it's okay. So now we're gonna do law of sine. So I'm gonna do sine of 7, and 7 is a really small measurement, so that might kind of throw you off there a little bit. And then I'm trying to find y because it's part of this triangle. So I'm gonna do sine of 35 goes with y. So that's gonna allow me to find my y value there. So cross multiply, set equal. And those of you guys who did this correctly, maybe this wasn't even the way you did it. You might have gone about it a little bit differently. I'm sure there's other ways to get there. So this is not the height of the mountain. 5,647 is this hypotenuse of this right triangle now. So I just found y, and so I'm going to redraw this again over here. I'm trying to find x. I know 42 degrees, but now I just found this hypotenuse. And now I can just use SOHCAHTOA to find that x value, because that's a right triangle. So this is a two-part problem. This is definitely a tougher one, but I want you guys to be able to see problems that these smaller pieces are things you guys can do. Probably not something this complicated on our test, but so we're going to do sine here, opposite over hypotenuse. Now, one of the things, guys, I do want to point out is try to be careful about rounding. Be really careful in your rounding. If during the problem, if you want to go more digits, that's better. I actually leave this huge number in my calculator, and I'm just going to multiply it the way it is, the answer, times the sine of 42. It just gives me a little more accurate answer, or closer to what we're looking for here. So the mountain, which I don't know if this is really considered a mountain then, if it's only like under 4,000 feet, but you know, if you were climbing it, it'd still be tough. Are we okay there? All right. And we're going to finish up with our last one again. This obviously isn't an overall encompassing review, like this isn't telling you everything that's going to be on the test. The review that you'll get for homework is more similar to that. I wanted to talk about angle of depression, because that was something that I saw a lot of people make mistakes about. So, oh, sorry.
The thing, helicopters, when they descend, they go straight up.
Right, yeah, sorry. This really bothered you. Sorry. Change it to an airplane then. No, they don't. Yeah, I suppose they do go straight down. Okay. I got this question from somewhere else, but yes, you're right. So a helicopter starts, I guess sorry. I'm not a helicopter pilot. Okay, so apparently if you want to call this a plane or a hang glider or a bird, whatever you guys want to do. So not a helicopter. All right, so after flying at an altitude of 500 meters, a hang glider starts to descend. All right, so we're at 500 meters in the air. They start to descend when the ground distance from the landing pad is ground distance across the ground. What's the angle of depression for this part of the flight? So again, picture that the cat, I was going to say the dog in the tree, the cat in the tree problem. The angle of depression, remember, is what the cat's looking at. So he looks straight out and then looks down. So when we talk about angle of depression, it's technically this angle. And a lot of you guys were calling it the other one. So it's how your line of sight looks down. So we're not looking like straight down, we're looking down, we're looking for that angle. Now, that angle, you could like draw another triangle here, should be the same as this one. They should be equal. So we're trying to find that angle. We're just going to do trig to just do the inverse trig function to find that angle. So understanding the angle of depression and elevation are the same angle, and a lot of you guys were calling that the angle of depression. So be careful about that, but it wasn't just one person that was doing that. Like again and again, I kept getting people that had that opposite angle or that other part. So, yeah.
If you find the angle on the top, would that add to 90?
Yeah, because this should be a right angle. Yeah, so a lot of you guys would give me this one and I was like, you're so close, because I could tell you just needed to subtract 90 from it, or 90 minus that. That would work. Otherwise, you could draw it this way too, that we know this is still 500 and that's still, so it's up to you. But we have opposite over adjacent, so this is tangent of our angle x is 500 over 11,000. And so we're going to do the inverse tangent, and that's going to give us the angle of depression of whatever flying instrument actually descends that way. I don't know. My best friend from high school went into aerospace engineering, so she probably would be really annoyed by my faux pas there too. So she worked for NASA for years, but now she works for the U.S. government and Boeing and builds fighter jets. Yes, what's up? What's going on here? Yeah. And 2.6 degrees. Yeah, that's the angle of depression. But then you have to do the inverse tangent of that. All right, questions there? All right, let me get our announcements up for today. Yeah. proficiencies, agri-science fair, all this other stuff. Come for the whole time or stop it at any point. Goal is to get all participants logged into the FFA profile account. FBLA, guys, FBLA is meeting tomorrow, Thursday during lunch. See Mr. Bills if you need a pass. Reminder that tomorrow we should all be wearing blue for Veterans Day. Fitness center, you can sign up to work out in the fitness center during your AR. And then remember that tomorrow Inspire Sheboygan is here, and Friday University of Wisconsin-Milwaukee is here during AR. I'm not sure. Does anyone else know what Inspire Sheboygan?
Yeah,
We'll get you guys. I just need some hole punches. Unless you. I just gave you guys enough space here.
I hate when teachers don't give enough space, so they need or especially when you're on spring walk
What was that?
He's trying to snap, he can't snap.
You can't snap.
He's trying to
Yeah.
snap.
Actually,
Can you do it with that so much?
it's not a baby.
Are you gonna give us like cheat sheets too?
Well, you can. Sheet of paper for your cheat sheet. So
Do you want one cover?
sometimes if you want, you don't want that paper.
Easy shoulder.
He can write like the most perfect straight words. So. Oh shoot! I forgot to stop this. Sorry.